So hello everyone. In this video, we are going to discuss more about the naive-based na classifier and spam classification. So in the previous video, I have introduced to you the Bayes rule, and it has this equation. And to apply that into the spam classification problem, we have the probability that an email belongs to a certain class, which is either spam or ham, given the bag of words in the document. Okay, so given this probability, so how can we classify that a certain email is indeed spam or ham? Okay, so naive Bayes is a probabilistic classifier, meaning that for a document B, out of all the classes C, the classifier returns the class which has the maximum posterior probability given the document. So it may be represented into this equation, wherein the C hat is the estimate for the correct class, and the posterior probability is the P of C given D, or the probability that a certain document belongs in a class na C given the document. And what we mean by argmax here is that this classifier will return the class which has the maximum na posterior na probability. So in other words, let's say we have the probability of an email being spam given the document. And then we also compute for the probability of an email being ham given the document. So each of this posterior probability we will compute, and the one that has the highest na probability will be the class of that email. Okay, so and we know that this posterior na probability may be computed from the Bayes na rule, wherein the Bayes rule is P of D given C times the P of C, which refer to the likelihood and the prior divided by the marginal. Okay. So we are going to conveniently drop the denominator P of D for further simplification. And why? Because we are going to compute this equation for each na class. Okay? And the P of D doesn't change for each na class. We are always asking about the most likely class for the same document na D, which must have the same probability P of D. So we are going to simplify it by deleting this denominator. So after deleting this denominator, we will be left with the product of the likelihood and the prior. Okay, and we are going to compute this for all classes, and this estimated na class will be based on the one that has the highest na probability, right? So, and also we can represent this document by a set of features f sub 1 to f sub n. So in the spam classification na problem, these features will be the bag of words w sub 1 to w sub n. Okay, so the problem is that still this is very hard to compute correctly. So estimating the probability of every possible na combination of features, for example, every possible na set of words and position, would need or require a lot of parameters and a possibly large na training set. So due to these constraints, the naive Bayes has simplifying assumption. So first is the bag of words assumption that we have already discussed, is that we assume that the position of words does not matter. So suppose we have the probability of word 1 and word 2 given the class is essentially equal to the probability of f sub 2 and f sub 1 given C. So it does not matter. So for example, if we have the word whimsical and it appears on the 1st or 5th or the 20th na position in the email, it does not matter. So what we only care for is the frequency or how many times that word has appeared in the email or the document. So another assumption is the naive na part, okay, wherein the conditional assumption, independence assumption that the probabilities P of F sub I given C are independent given the class na C. So you can think of it like, for example, you have the words direct na evidence. Okay, it does not mean that direct is associated with the word evidence. So even if we know that the word na direct is an adjective to the evidence, so the naive na assumption is that these words are independent. All right. So that's why this is naive. So given that these probabilities P of F sub I given C are independent, so we can then use the product rule to compute for the individual na likelihoods of the words or the features. So we have the P of F sub 1, F sub 2 until F sub n given the class na C will be equal to the probability of F sub 1 given C times the probability of F sub 2 given C until the probability of F sub n given C. So naive Bayes na classifier will then return the most probable class na C by choosing the class which has the highest na product of the two na probabilities, the prior P of C and the likelihood of this independent na conditional na probabilities. So P of F given C. Okay, so this part, the large na product na operator is essentially just equivalent to this equation. All right, now how can we apply naive Bayes na classifier for spam na classification? So to reiterate the assumptions of the naive Bayes, first is the bag of words assumption wherein the position does not matter. These are similar, okay? So it doesn't matter if nauna si Viagra then followed by the word offer or if nauna si offer then followed by the word Viagra, okay? And also the assumption of conditional independence. So to apply the naive Bayes na classifier to text, we need to consider the word positions by simply walking an index through every word in the document. And we are going to compute for the independent na conditional na probabilities. Right? So in this example, we then have, suppose we have the word na Viagra and offer. So we compute for the probability that the word Viagra appears given that the class is spam times the probability the word offer appears given that the class is spam. Okay, so we just multiply the probabilities.